In this video, we are going to solve an optimization problem. Let us read the problem. A farmer wants to fence a rectangular area of his rice field that borders a straight river. He will use the rectangular area for rice seedlings. The part of the area along the river will not be fenced. What dimensions should the rectangular area have in order to enclose the largest possible area using 240 meters of fencing materials? This is the illustration. This is the rectangular area for rice seedlings, and this is the river. Solution. Step A. Form the constraint equation. Let us look at the illustration again. This is the rectangular area for the seedlings. This is the width, this is the length. This side will not be fenced according to the problem because it is along the river. So the perimeter is x plus y, or p is equal to 2x plus y. This is our constraint equation. So the constraint equation is p is equal to 2x plus y, where p means perimeter. The fencing materials is 240 meters according to the problem. So we are going to substitute 240 for P. So we have now 240 is equal to 2x plus 2y. Then y is equal to 240 minus 2x. Step letter B, form the optimization equation. The area is equal to x times y. That is, it is equal to this width times this length. Substitute 240 minus 2x for y in a is equal to xy, where a means area. So this is now equal to x times the quantity 240 minus 2x. Apply the distributive property of multiplication. X times 240 and then x times negative 2x. So this is now equal to area is equal to 240x minus 2x squared. Step letter C, find the first derivative. A prime, or the first derivative, is equal to 240 minus 4x. Step letter D, find the critical value. To find the critical value, we equate the first derivative to 0. The first derivative we got in step C is 240 minus 4x. So we equate this to 0. We have now 240 minus 4x is equal to 0, and then solve for x. So negative 4x is equal to negative 240. That is, we transpose 240 to the right side. We changed its sign from positive to negative. And then dividing both sides by negative 4, x is equal to 60. Step letter E, use the second derivative test. The first derivative is A prime is equal to 240 minus 4x. Then solve for the second derivative. The second derivative is the negative 4. This becomes 0, and then the derivative of this one is negative 4. So the second derivative is less than 0. The second derivative is less than 0. Therefore, the maximum value occurs when x is equal to 60. In step A, we got the equation y is equal to 240 minus 2x. Substitute 60 for x and solve for y. So this is equal to 240 minus 2 times 60. And this is equal to 120. So y is 120. The dimensions that will give the largest possible area are 60 meters by 120 meters. So x, which represent the width, is equal to 60 meters, and y, which represent the length, is equal to 120 meters.